Well, hold on. I'm going to write it down. I'm not going to ask you to write it down. All right, so if we think, Jake, this might be for you. I don't know if it will or not. Today's the 26th. This video is just for Jake. Thanks, Jake. You liked and subscribed and left the best comment. No, I'm joking. Somebody,
I don't even think he cares about the videos.
No, I was watching something last night, and they were joking about, like, they looked up directions on how to put together a cabinet, and it was like, but before I put up this cabinet, why don't you comment on the video and tell me, like, the thing that you like most about me, the best comment will get a shout out. And it was just this joke about,
Never
like,
mind, my equation's wrong.
oh.
I tried to
That quickly you abandoned your equation?
Okay, so I tried to take, like, it still kind of could work. It might be useful, but I tried to take, you know how, like, the square is the amount, it's the length times the width, and the triangle is the half the length times the width.
Okay.
But that doesn't work if you go up more shapes, because they can be all weirdly shaped, and then your length times your width is just a square around it, so it's still a fraction.
So we're working with regular polygons, right? So they're
Oh.
nicer than just any polygons.
Yeah, you're right.
So if we're talking about areas of regular polygons, because then we'll mess with it and see if it works for any polygons.
Wait, is there such thing as a regular, like, right pentagon? Is that the thing?
Regular right pentagon?
Can
What
both
what
sides-
even is a right pentagon?
It's like where it's got the square and it's got the isosceles triangle.
So a right pentagon is,
A square and an isosceles triangle.
so this is what I continue to circle back to, where I'm going to push you to be more mathematical now that we're in the second half of the year. Don't give me a frou-frou half effort
It
definition.
has two right angles.
Okay, so if we're going to define a right pentagon, so it is, first we can do the easier part and say it's a five-sided shape
Oh, yeah.
with
Two right angles.
two right angles. So could that be regular? What is a regular polygon?
A shape with all the same. Does it have to have all the same angles?
All equal sides and all equal angles. So could a regular pentagon be a right pentagon? No.
But could you have a pentagon where all the side lengths are still the same? But
And it's right?
Because,
I don't
like,
know.
The isosceles triangle can go up.
I don't know. We can play with it. We can find out.
I think you could. I just, what would that be called? What is it called when a shape has all the same side lengths?
Well, so if I try
Right?
to make like these look the same, so you're saying
Well, you could just use the, you could use
that,
the
so
right
now I'm a right pentagon. You have a line tool won't fix it. Then I can clone it, right?
and then make the
Then-
lines make like an isosceles triangle out there. Yeah.
Oh, so you just talking about like a house,
Yeah.
right? Isn't this
Then
just
how
a
about
house?
Most houses don't look like that.
Well, that's how Peppa Pig's house.
Yeah. Like,
Yeah, those are all equal, I think. I mean, so when you ask these questions, you then need to follow up your first question with what other questions need to be asked.
wait,
Right? When we say, can we?
wait, is that just an equal? It is. It's an equilateral triangle on top of a. Oh, that's cool.
Oh, because you're saying that this length then is the same.
Yeah.
So it's an equilateral triangle on top of this. So you're saying the area of that, we could solve as triangle and square. Okay, but you're beyond where we're supposed to be.
Oh, did I skip something?
You definitely skipped something. We
I
haven't
just
done regulars
wanted to
yet.
know about- I just-
All right, so if I draw a square like this, go ahead and jot this down in your paper.
It's radical
You said
to.
we didn't even have
It's radical to 6 times 2.
What?
What?
What are you trying to solve?
The area of the square.
Fine, maybe you don't have to get paper if you're gonna get
Okay, so it's
You're
radical.
gonna have to do this on paper eventually.
It's 12 radical.
So wait, what are you saying is what? So
Okay,
you're
so-
just saying numbers
Wait, no. Radical.
and the word it. but-
Okay. So, wait, square. Okay, anyway. 6, since we know that's a right angle, and we know
No,
that interior. No, that's not 6. That's
No.
that's radical.
This
to
part is 6, right? That part? Or,
Yeah.
Yeah.
That?
Yeah.
Because it's nicer to write the integer first, just for notation.
6
Because
radical.
if you write this, it's just not as nice.
It looks kind of like radical.
Yeah.
6.
And actually, this is easier to type into the calculator too. Literally, to hit your 6 and then hit your radical symbol and hit your 2. You close parentheses. But even if you don't close your parentheses, if it's the last thing you type, sometimes it doesn't matter. But you should always close your parentheses.
So, because we know it's a right angle, and we know that we know all the interior.
So it's isosceles triangles because it's 45, 45, 90.
Yeah.
And then because it's 45, 45, 90, we know it's 6 radical 2. And then because it's a square, what do?
We square that, not multiply it by 2.
Not multiply it by 2, square it. Now here's the tricky part.
36 times 2.
No, because the square root of 2 is the
yeah,
square root of 2,
oh.
which is 4.
Plus
and
12
that's
radical 2?
2. And then 36 plus 36.
Is it 36 times 2 plus radical 2? Right, 12 radical 2?
So
I think it's
We can FOIL it out.
when is FOIL used?
binomials. At least that's what we
Because
use.
here's the
On the
debate.
SATs?
Here's the debate you should be having in your head. This
Oh,
is
right,
the
it's
trap
72.
door.
Because it's 72. Oh my god. Okay.
Oh,
So
no,
it's
I was
72
having a
because-
different
because
debate in
it's
my
6
head.
times 6 is
I was
36.
having,
Okay.
wait, can I come up to the board? I was having third debate. 6 radical 2 times 6 radical 2, and then FOIL.
When do we use FOIL? For binomials. Are those binomials?
No, they are not.
Listen, there's 2.
No.
Wait, what is binomial?
Binomials is
What is a binomial, he says? Refer to the algebra alphabet.
two.
Oh, okay.
Sorry, I said he, my apologies. So,
Yeah, there's no plus.
yeah, Connor.
there's no plus or minus. So now wait a minute. Careful before you throw shade. Make sure you yourself are not in the shade.
I didn't because I checked it on decimals.
Oh.
So what I did was 6
It's-
times 6 is 36, and then 2 radical 2 times radical 2 is radical 4, which is 2 because it's a perfect square. And then so I did 36 times 2, which is 72. Great.
It's actually it's this one, and it's get rid of that 3. I think it's also that one.
What?
Wait, no.
That-
Wait, because right, you
But I
can
checked it
either
on
square the
decimals.
radical 2, so it's 6 times 2.
According to decimals, I'm right.
Okay, well then it must be 36 radical 2. I mean 36 times.
If this was a binomial, we would need to FOIL, right? But it's not. So first off, throw away your idea of foiling. So now that we have 6 radical 2 squared, what I want to get you guys in the habit of doing.
Is writing everything out?
No. Can you quit acting like I'm the enemy?
I'm just saying.
If this was 6x and we got asked to square it, what would we end up with? 36x squared. Yet, when we do this, people have this moment of, do I square both of them or do I only square one of them? Because if this was like, it's mixing up all the different types of math that we've done, right? So this is one term. It's not a binomial, but it's got 2 pieces. And when we have 2 separate pieces and we go to square both of them, this square is effectively distributed, right? So the square applies to both the 6 and the radical 2, and
It's
this,
a times, not a plus. Okay.
because it's a times, not a plus. If it was a plus, we would have to still like distribute. However, then it would be like FOIL. So does it make sense why that becomes 36 times 2, which is really 72?
Well, I didn't know that, but you said it.
Oh, you did.
Well, I could have done it in my head, but I don't remember that.
So then, okay, a regular hexagon that we now have the edge length for. So we didn't have the edge length before, but then we derived it.
Well, I know one way we can do this.
What's one way we can do this?
Wait, what's the interior angle measure of a regular hexagon?
Well, why don't we do math?
Oh no, we need a right angle for that. Never mind.
What?
You keep bailing on your ideas really quickly.
Well, we could get a right angle. It just would take work. like make a vertical line from that corner down? No. Okay.
I'll make whatever lines you want, but I want to make the lines I want first.
Okay.
It did look nice until it shifted down a tiny bit.
Just like a tiny bit, and it just ruined the whole image. I'll live.
Whatever. I give up. So then you want a vertical line.
From just like the left side, sure. I feel like I've made this harder on myself because you already made equilateral triangles, but you know, I don't care. Okay, so now we have, if I remember, wait, what's the equation for n?
N minus 2. Wait.
Oh no, don't do that one. That one's ugly. Wait, actually,
And now I'm just drawing.
We could use that one.
Now,
There are
oh my
two
gosh,
ways
you
we
made
can do this.
you made a rectangle.
There's 30, 60, 90 triangles there. And well,
You
yeah.
made a rectangle and 2 triangles.
Yeah.
Dr. Smith always used to say, if you don't know what to do, just draw.
Dr. Smith.
Okay.
I've talked about him before. He was my favorite math professor.
Yeah.
Here we go. Okay. You know what? Since you already did this part, we might.
Hey, would you like this?
Sure.
I don't know where my other one is. It's right there.
We might as well just do it this way, right?
Hey, don't use that. Yeah, make it smaller. Thank you. Just don't write in super thickness.
This is a bitty 4, and this is it? It's rack 3. Okay. 4.
Just do an arrow. Or not.
It's right.
Wait, the vertical one or the diagonal one?
See,
The
that's what we
diagonal
don't
one is
know.
8.
What?
The diagonal one's 8 because it's 4 times 2. And also equilateral.
How?
8.
You know?
I think we skipped over labeling of some things that are allowing us to say this.
This is all there. There you go.
Are we referencing the right triangle or the isosceles triangle?
It's an equilateral triangle.
It's a new. Oh, because it's a hexagon. We get lucky again. But I don't think this will work for any hexagon.
But we're doing regular hexagons.
Or I don't think this will work for any polygon. Sorry.
Oh, no.
So we might want to be careful that the method we derive here should work if we turn this into an octagon.
Well, then why didn't they do it with an octagon?
Exactly.
Maybe that's going to be like next.
Oh, well then we can do that next. Cross that bridge when we come to it. So this is 4 radical 3. And then you just multiply.
This one, the other leg, or the hypotenuse?
This.
Okay. Great.
Which is the same as this over here. So it's just, so this would be, this length over here is 8 radical.
So
Is it 8 radical 3s? Yes, it is.
It's okay. This is a square. Can't we just
It's actually a rectangle.
Okay, yeah, but
Times 8. So we got 8 radical. Wait. Okay, I'm good. So we can make this simpler.
I didn't do that.
No, that's not what I meant to do.
Okay.
No, that's also not what I meant to do. Oh,
Good.
can you scroll down, please? Thank you.
What do you want to do?
Undo. I just forgot the button combination, okay? No need to be so rude.
No, that's what I was thinking.
64 radical 3. That's what the red shape is.
Right.
And then we just need to solve for the other triangle.
Yeah, which is 8 and 8.
And 8 radical 3.
Yeah. So then.
But we need this line.
We need that.
Oh, that's 4.
Yeah.
So take radical 3 times 4 over 2. So that's 16 radical 3s.
So then you have to add all that
So
together.
that's
And then there's another one.
80 radical 3s. Oh, yeah. 96 radical 3s. Now, is there any correlation between the number of sides of this? I really feel like there is. Because like,
Because 9.
there's 6 sides. And 96, well, evenly divides into 6.
8 times 12 is 96.
8 times 2 times 6. 96. Just doing that because there's 6 sides. Let's see if that works on another sheet.
Okay.
Wait, what if we just do it over here?
Click the right arrow.
no. Oh, okay. But we don't have the equation over here. So let's just do it on the square first, which we already know the answer to.
So that's
Then
6
it's better,
times 6.
you know? So it's 6 radical 2, because that's the outside line, times 2 times 4. So 6 radical 2 times 8. Wait. Radical 3.
No?
But what do we
Wait,
do?
where'd you get 8 from?
4 times 2.
But then we need a radical 3.
How?
Multiply it by a radical 3.
Oh.
But does this equal? Does that equal 72?
Let's check.
No. Wait, am I?
I don't really think so.
Is radical 2 times radical 3?
No, it's not.
That's like radical 6, isn't it?
Yeah, that's
Yeah,
what
because we can put radicals together, right? So this would really be 48 radical 6.
Radical 6.
What's 48 radical 6?
I'm doing it. I'm also working my arms.
Well, radical 6 is going to be 2 point something.
It's not low.
That's not right. Okay. Yeah, it's not good. Okay.
It's not good.
So either what we thought of has a mistake, or the work we did has a mistake, or
There is no relation.
both, right? Or like what we thought of doesn't work and we made a mistake.
Oh yeah, well that could be true too.
So wait, explain to me what you did in the hexagon that made it work?
Rectangle, triangle.
Yeah, that feels difficult though. Is there a way that you could do that without? So you told me to draw that vertical line, so I did it because I do what you guys
Wait,
tell me. But
there's
hold on.
another thing.
I will let you say wait,
You're right,
but I'm
you don't
going
need
to
the
clear
ruler.
your ink first. Yo, you're still over here. It's still right there. It's okay.
Wait, what? What?
What?
Oh,
I
oh.
cloned it.
Were you talking about like? No,
Yeah, you
No,
gasped.
I wasn't like.
So,
offended.
This looks
I think
nicer
we
to me.
actually kind of do need that one.
You think we need what?
That one last line.
That one last line?
Yeah. Cause right.
Give me 2 seconds, because I'm going to blow that up. Get some C4.
Cause
Get a
like
detonator pin.
we could just do 8 times 8 radical 2 times 6, right?
Alright, so you said, because I think it's easier to do this with the mouse than it is.
But again,
On the
that's
board.
only because it's a nice.
So you
way
said
to
do the other line.
the middle one.
I'll move that over in a second. But then should we also do these? If we're going to do that middle line?
No, we don't need those.
We don't really need those? Okay.
Because we only really need to solve for one of these equilateral triangles, then we can just like expand it.
True.
'Cause this is.
So wait, hold on. Because if we try to work smarter, not harder, I agree with you that we have equilateral triangles here because it's a hexagon. But I will tell you the next shape we're going to do is 1, 2, 3, 4, 5, 6, 7, 8, 9.
And it's showing us its radius. Thanks for that thing. Oh.
So we have a nonagon next. So let's not use equilateral triangles because that won't, we know that won't work on not a hexagon. Right? And this is what I keep trying to push you guys to do, is think efficiently. Don't think about one situation. Try to think about many situations.
Well,
So like applying this to any regular polygon. So what you know about regular polygons is this will always equal this, and these distances will always equal each other, right? Like, so this is actually from the center out is what we call, and you already said it, the radius of the polygon,
oh.
right? So this is the radius of the polygon versus this is not. This is an altitude, right? Because it makes a 90-degree angle. We said altitudes make 90-degree angles. So go ahead and keep doing what you guys have been doing, but I would encourage you, don't use the equilateral triangle.
Okay. So these are equilateral. Let's just describe some of the stuff we just.
It's gonna be the same.
And maybe could we speak in generalities? Like, I mean, you can use.
Sides have to be congruent.
Yeah, but that looks like a 7.
Let's change.
Yeah, I know.
We could change it instead of 8 to just be like n. Wait, no, because it's the side.
You can make it L if you want to make like side length. But I mean, you could use the 8 here and then go back and replace it. So go ahead and use the 8. I don't want to overcomplicate it yet.
So we do know that this bisects this. If we don't want to use it.
Hey, so I'm going to write 8.2.2 as your homework today, but it's also tomorrow. Because then Jake will be here. And we're not really trying to get the lesson done today. We're just playing
Wait,
with
is
the
this
math.
another 2-day lesson?
Yes.
2 days.
So today counts as day 1.
Which means
Friday
really
we will
far
do
behind
8.2.3.
on homework now. Okay. Well, we know that much. What else do we know? We know these angles are congruent, right?
Can you? So hold up. We know trigonometry. So I'm surprised you haven't marked the right angle yet, and maybe you just don't care because you know it. But I would always mark the things that we know.
Okay.
So we know the right angle. Can we? Could you figure out?
Hypotenuse like congruent.
Could you figure out the central angles?
The central?
Like these ones?
Yeah.
We know, like, you mean the angle up here?
I don't know. Can we figure out the central angles? That's the question I'm
Well,
asking
we know
first.
it's 360 divide. Okay, so let's just start writing this down because this is also true for all shapes. Divide by.
Can I rewind us 5 seconds
What?
and quote Connor Morris saying, "Let's start by writing this down." Just there's a quote from you. Just by the way, it is recorded. It is evidenced.
Oh shoot.
You just told me to start by writing things down.
Okay, so we know that's 360 divided by 6 in this situation, which gives us 60. Right, and that is the degree of this entire angle. And then it has to be split in half.
Do yourself a favor. Label that 60 in one of the other triangles that doesn't have the bisected line.
Oh yeah.
See, I would do that just so that you can keep it there.
And then we know
So
divided
that's
by 2,
30.
they each have to be 30.
Yeah.
So you could mark that 30 in one of the top ones if you want, or whatever. Like, just try to
These
keep
are
things
also
clean.
30, but we can't use the equilateral
Oh,
triangle.
wait, what's also 30?
That's
These
30,
ones down
that's
here.
30, What?
They are, but
Oh, yeah.
we can't.
Ah,
really
wait,
use
hold
them
on.
for it. That's
Hold
fine.
on. There was hesitation and then there was just quick acceptance.
Isn't
You're
that
saying this?
Wait, no.
No,
You're
no,
saying
60,
this is 30?
It's 6.
That's
I was
60.
Right. Okay.
Yeah, do not just quickly accept something because you assume that they are, like, correct. Always let your
I'm
hesitation have a
always
moment.
right. What do you mean? Okay, so wait.
So 30, 69.
So, we've
Yes,
got
but that's
the
because
30.
the equilateral triangle.
We've
can't
got
really use
the
that
6.
part.
So you're right that this works nicely because it's a hexagon.
Wait,
But
what?
here's my question.
We can use y. Oh, okay.
Go ahead. If you think
I
we
was
know
gonna
where
say,
we're heading
we
from
could,
here.
We could use y30 60 90 works to like expand into all shapes.
Because we need to think about, okay, so they won't all be 30, 60, 90 relationships, but won't they all be right triangles?
360 minus n. I'm just gonna do this so that I feel better about life, you know?
Okay.
I'm just gonna say that this
It's the-
equals, what should we call the variable? It's the angle method, so we'll call it A. Right? Just so we
Yeah.
can do it for any, instead of writing 360 divided by n. And then, so A is what, these interior angles are always gonna be A, right?
Yeah.
Yeah. So it's the, is it the sine? No, it's the tangent, right? Tangent of A
So good.
times the half of side length, right? Tangent is opposite over adjacent
Yeah.
Yeah, so
good,
tangent-
yeah.
of A times this, which is 1/2 side length,
Yeah.
equals that distance. Do we need that distance?
That's kind of scary. Okay. Wait, so are we trying
Oh yeah, because that's okay. Yeah, tangent of A times 1/2 SL. Sure. Side length.
Wait,
And
are
this
we trying
equation
to
A
figure
equals
out
SL.
this?
that is what this
Okay, yeah, great.
equals. There we go.
Okay.
Wait, we could actually make it a legitimate variable.
Like
What would that be?
D for dot. Great.
D. Okay, and then the D times. Okay, wait. So D times SL.
Hey, just for what it's worth, the way that you make your D's is actually a Greek letter, and if you're going to continue to do that, you should just call it by its Greek letter name, or you should make your D's like they look like English D's. There we go. I mean, it's just the fact that the tail of your D is so curvy, and the top of it is so, they look like the fish, which that's a Greek symbol.
It's Pez.
Hexagon.
Pescado.
It's not dead.
Okay.
All right, so
So,
you're saying we're going to use tangent.
and then this times the number of wait, just 1 second. Times n equals area. You know, using A probably wasn't the best idea.
See, these are the things we figure out as we play with math, that like avoid certain variables in certain situations. Okay, so we don't even have to work this one all the way through to like start playing with will this work?
Yeah.
All right, let's play with will this
shoot.
work. So hold up. Do you want B or C? Do you want A or B first? Do you want it to have the radius or do you want to have the altitude?
How do we do C?
I mean, you could do C
No.
first,
These
except
guys
it
are
is still a
easy.
hexagon, and that's the thing.
And
We
we
want to
already
try
have
it with
a
not
side.
hexagon.
So what are we gonna do?
Okay.
So,
Doing this one?
which do you want, A or B? All right, I was gonna make it bigger for you, but okay. I'll call
Okay,
you
wait,
back.
what was our equation?
Okay, love you.
You good?
Yeah.
What was the equation we had? Because we have a different thing here. We have. I don't even know if we used this last time. Oh, okay, yeah, we're gonna need that. But how do we?
So we said this is a non-gon.
Yeah.
3, 4, 5, 6, 7, 8, 9. Huh. Non-gon.
How do
It's not-
we translate?
Oh, it's a non-gon. Just non-gon sounds fun to say.
How do we translate the radius? This is a completely different thing we gotta do now, though, because we gotta translate the radius.
Oh man, he changed it. He made it harder again.
You made it differenter.
Differenter.
It's not like it's harder. Like it's harder math for the same like situation. It's a
Oh,
completely different situation.
I mean, yeah, only in the case that it uses the hypotenuse instead of the opposite or the adjacent.
Well, also in the case that I don't know if we have any angle then. We do.
Yeah, we did.
What angle do we always know?
All of them.
All of them.
Yeah, right? That all of them together.
It's 36 over.
7 times 180. What are you doing?
It's a nonagon. It has 9 sides.
No, but then.
Oh, you're deriving the angles at the vertices. See, I'm lazy and I would just derive the central angle.
Yeah, I feel like the central angle is just better. Like it's just 360. It's just 40.
Actually, I think you're outvoted here.
We don't
It's
need
2 to
that.
1. It's 2 to 1
We
now.
don't need that.
Connor and I agree. We want to do central angle. Sorry.
We're gonna change to red just to mess with your brain.
Okay.
40.
That actually helps your brain. So wait, hold on. How'd you derive the central? So you did 360,
Divide by 9.
which was,
40.
and that meant that those are 40?
Yeah.
Where at the bottom, this angle?
Not
Or
the whole
this
angle,
angle.
just
Oh no, it's not.
Hey, you know what might help? Hold up. You know what might help here?
making it bigger.
Let's blow this up and
Yeah, let's
use
make it bigger.
just a different, like, ah, crap. This does isosceles right triangle. Where's my regular? Here, let's just do this. Let's blow
Because
this
all
up
we
so
have
we
to
have.
do is really take this and then multiply.
All you really need to do is look at one side of this, right? So go ahead and draw to your heart's content
Okay.
there.
Yeah, sorry. We know that this interior angle is 40. And
So
divide
the like top
by 2. And we know
angle.
that these have to be 180 minus 40 divided by 2, which would be
Wait,
7.
what is 40 again?
This top entire angle.
So for the isosceles triangle.
Yes.
So for the right triangle,
It's 20.
ah, Yeah, for the right triangle,
Look.
we have to cut that central angle in half.
Oh, I guess it doesn't matter either way because we know this is a right angle, so we can just do 90 minus 20 equals 70. So you can get about it differently.
Oh, yeah, no, you're right. I get what you were saying, is if we worked with the entire isosceles triangle and the 40 degrees. Yeah, I'm with you now. I agree.
In here, all we do is we take the 70 and you do like...
So the reason that I'm pushing
Sine
you guys to
cosine.
use the right triangle is we're gonna end up doing trig, right? So since we're gonna end up doing trig, we should think about the right triangle.
Why do you... Oh, now I get the entire
I
point
think
over
it's
over.
time for lunch.
Yeah,
But
great.
you don't just remember tangents opposite over...
I just like writing it out so I don't mess it up.
Here's the deal. If you take some time to try this on paper, like, I don't know, if you attempt the homework, I guarantee you will have some breakthroughs in like, oh, this always works, this always works. So even if 821's not done, if you want to play with this and continue the exploration of how can we derive a clean formula, start 822. Find a couple problems
It's
that
not
deal with
that
this.
so much as like, I should have done homework in AO today, but I was feeling like a crybaby,
Bye,
so I
thank
didn't.
you.
Have a great day,
And
Ache.
then,
I mean, we're all allowed to have an off morning. That's
I don't
okay.
have extensions time really.
Because wrestling.
Yeah, and then after wrestling, I normally never feel like doing
So,
homework,
then Connor, if you need to hear this said, you do not have to do any math homework tonight. However, if you're behind, it might be a good idea to do some if you can. But 822 can just be thought of as tomorrow's homework.
Yeah.
Does that make sense?
So like, I think of all the homework as the end of the chapter's homework, and I just get it done.
Shh. That's our little secret.